Oh, all right. Okay. So this becomes serious now. Yes. So what is the problem? What do you have to do now? How do you start? Yeah, okay. Yeah. 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 All right. Avoid the instructions. Yeah. Have you used open form before? No. No. The first time. Right. Yeah. I think it's pretty useful actually because you can just get it for free as well. And but you don't do any simulation in your work now in your research in your own research? No. Yes. Yeah. No, that's all right. I'll just follow. So, so you probably know better than the others because you do simulations, don't you?
Yeah, but this is the fourth software on CFD I'm going to learn.
That's right. What do you use now?
I'm working on console.
Right.
In
Okay.
my PhD, I use CFD
Right.
and
Okay.
I learn answers.
Yes. Yeah. Yeah.
So,
Yeah. But people kind of move easily, I think, from ANSYS to open form.
yeah.
Yeah. Especially for somebody like you, I guess, that with some experience.
Conceptually, I know.
Yeah.
Thing is the command structure and other thing. That's the
Mm.
only thing I need to know.
Yeah.
I
Yeah.
know what
Yeah.
is happening.
So you can find now quickly,
Yeah.
yeah, with some help. Yeah. Yeah.
Actually, I'm planning to move to open form
Okay.
because it's मतलब you know what है सारा समझ में आ गया.
Yeah.
So there are a lot of problems I'm facing. It's supposed to the framework is not that using that once.
Quite difficult, actually. Yeah. If you want to do beyond the, what type of problems do you want to do?
So right now I'm working on modeling of free radical polymer system.
Yeah. Oh, yeah. Okay.
So it's a couple of table dance. So still faster and
Okay. It's very challenging. Have you worked before with this clear problems or,
might be technical there.
yeah. Okay. 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 Yeah.
So the problem is if everything is running, it's nice. But once you start, it's really difficult to figure out where from which are figures. It's not that with the pending background.
Mhm, mhm.
Changing different parameters without knowing what is happening.
What is your, yeah, yeah.
So
I mean, even the technical support, I mean, maybe we should be recorded on that, but sometimes can be not so good.
it's been
Technical support from
technical is not there, but it's like
if they have not done it themselves,
them every time. It's like sitting them with them all the time.
and also if they have not done your problem, they may not
They are
know.
not there.
Yeah.
So they are also and that's expert in seven things. So
Mhm,
it's like
mhm, mhm.
stuck the best you can do.
Yeah, yeah, and then sort it out yourself.
So ultimately, say, if you want to sort, it's better to work on this. At least you know what to do.
Yeah, yeah,
There you cannot touch anything.
yeah, yeah.
Okay,
Yeah.
it's like when we learn or teach CFD, it is basically FBM. This is on FBM. So the solvers, the techniques that are being used, yeah, we are very much.
Mm.
But those are techniques and formula around FBM.
Yeah, yeah,
So their solvers are different. But
yeah, yeah.
you don't know what choices to make. Those solvers exist.
No, no, no. You have to trust that, and yeah,
So you have to
yeah,
start from the program.
yeah.
Then I am
You teach safety as well. Yeah.
so I used to teach them
Yeah.
right coding method.
Okay, right. Yeah,
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 same
yeah.
friend doing MATLAB.
Yeah, yeah, yeah. Yeah,
I used to teach.
yeah. Okay. Yeah, yeah. Yeah. So now you don't deliver any course on safety.
Currently,
Yeah.
most code mechanical courses. So
No, sure. Yeah, but to say that is also a good thing to use for teaching, isn't it? Because you can get them started and yeah.
well, there was a top we were planning together. Only thing is my course load changed. Right? So I was now taking different course.
Okay.
I can fit all the code.
Oh, no, no, no. No, no, for sure. What do you teach now? Is it?
Process engineering and
Okay.
process safety.
Okay, 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 okay.
The next semester, we have a industrial course, natural gas engineering.
Okay, sure. Yeah, 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 yeah.
From gas authority of India Limited. They are from the natural gas sector.
Sure.
So they come.
Right, it's like an industrial, yeah, industrial, you mean deliver to industry. Yeah. Right.
Industry. Just to people know
Okay, right, so you run it with a lot of,
so it's more than
to the industry.
But we have to go to the documents.
sites. For
What we have already.
No, that's good. So how big your year in a year? How many students do you have? Like it's a chemical engineering degree. So how many students per year do you get? Do you?
in our university,
Yeah.
in our university, it's around 20, 24, 25.
Okay.
Translating to 30 classes.
Yeah. Okay. So that's what I was thinking. It's this industrial course is nice. Sometimes if you have big numbers, it might be difficult to arrange the visits and everything. But I think if you have a student population of, I don't know, 25, 30 students, or is it? Oh, I see. Okay. So you get,
Industry, everybody is required for that. So you want to explore schooling system.
Yeah.
Aspects of industry.
yeah.
5-1, 5-4, 5.
Natural gas industry, when you are running on
Different match.
Yeah.
and
Okay.
you will
Documents, load.
So it's course not just for the chemical engineers, but for the whole, yeah.
measure everything that is mechanical. Stuck at
Careful, man.
Mm. So how many students do you collect in that course?
And
13 students are
documents load over
Yeah.
there. Documents.
Yes, so that's a good idea though. I think it's very good idea. If you can do this visit, it's because a lot of departments can do it these days. It's very difficult to arrange that. Yeah.
doctors are there.
Yeah, that's yeah.
That's why
huge
it's
for you.
really
Yeah.
good.
Yeah.
So we take them
Yeah.
site, explain everything, show them which is how big it looks like.
Exactly. Yeah, it's not like just that. Yeah. No, it's
So they get for the first time like, okay, it's not
Momentum
that
trans-
yeah.
good. And that
The
is
first time. And but that's good. Yeah. Should let you do your grid now. Do you know how to make a cylindrical geometry? Let's see. Good luck. I'm not you. Yeah. Come on, you need to progress.
Momentum transport equation.
Let's open that first. Yes. Sorry.
ब्लॉक में चलिए उसके बाद इनको हम
So how are you doing then? You look stressed. Yeah, no, yeah, that's right. Have you done any safety before? Council, yeah. Yeah.
11
It's a bit different, but okay, it's not. Good luck. Yeah.
हाँ आप जाते टाइम वो ले जाना बाकी हम
How are you doing then? Yeah, still struggling? That's still the beginning though. It's okay. Yeah. Have you done any safety yourselves in the past?
already
Or
installed
yeah? Yeah, right. Yeah.
in the INT
Okay.
after like friendly but
That's yeah, Basilisk. How much more user friendly is Basilisk? How much more user friendly is Basilisk if you want to?
I use I think that for any business I can do some simple simulation I can do.
Yeah, okay, firstly, because you just beginning, yeah. Simply, you mean what, like simplified flow or?
Testing over
Okay.
pricing over inside the
Yeah, so two phase in a way, but yeah.
making as well as the busting holes inside the simulation.
Okay.
I also can do the leaves which are the affect the on the field.
On the, yeah. Okay, that's quite advanced. Yeah. So, but maybe simpler geometries then, is it? Yeah. Yeah.
Currently actually I have a problem that we solve now. That was separate from the speed. It's my current problem.
Really? So because you cannot capture the physics, or what do you mean you have a problem?
The problem is that because the discuss because we have to solve the pattern discovery. This is not a tool yet, this is an
That's right. Yes.
is used for the tool yet.
Right.
Also,
Ah,
the interface.
yeah.
For second click, we have direction control the OFL.
Yeah. Yeah. Yeah.
Does understand the purpose.
Man,
Yeah. Okay. Okay.
I think that's why for me to say we are under the load.
Good luck.
We have open
Just focus. Fatal error already.
some simulation runs.
Yeah. It's okay. Yeah. Yeah. Right. So you have not done any coding at all. No. Okay. Okay. It's good to get the exposure, isn't it? Because if there is a need. So your experiments are on what? Oh, sorry.
ब्लॉक में
Mini chat. Sorry.
सब आ रहा है ये तो
What do you do?
आ रहा है समझ तो मैं समझ गया वो तो टूरिस्ट वगैरह मेरे मेरे सिस्टम में पड़ा है वो मेरे में आओगे वो तो
Okay. Oh, for the wetting properties. Yeah.
चल
Yeah.
रहा है
So that would be your PhD project, or yeah, so droplet formation and yeah. Right.
क्या ना कि हमें
Do you have any sort of applications,
वो एक लेवन
or is it just more generally the fundamentals?
लेवन में आपसे बना कर लाया था लेकिन वैसा होता है कि ये वाली मोमेंटम का
No, but they're there. Yeah. Where do you come from? Which university?
कोई नहीं कुछ सही कर सकते तुम्हें तो पता है ज्योमेट्री बनाना सिखाना
Okay, that's allowed. That's good. That's a very okay. Oh no, physics. So physics, and now you are starting the. So are you working with Professor Ghosh then, or what? Okay, okay. Master of physics. Yeah, okay. Yeah, yeah.
इसी में ओपन टर्मिनल इधर इसमें 5 0 में जाओ हाँ
I see. Okay. How long have you started? When did you start?
हाँ ब्लॉक में
Okay. So you're just doing the reading at the moment. Yeah. But actually, maybe it is an idea because you can do some simulations of the droplet formation. Maybe, okay, if you are mainly experiments, you are mainly experiments. But, I mean, I've also showed as well that you can actually do some simple simulations. So it might be, you get something to use. Yeah. One thing at a time, done. But yeah, good luck. Good luck with this first. Yeah. Yeah. Right, how are things here? How is it going? Yeah. Yeah. Have you done any simulations before? No. Okay. Okay. Yeah. So you're doing experimental work, what do you do? Yeah. What sort of systems? What are you investigating? Yeah. Oh wow. Okay. So this is but do you do it in small channels, or how do you do it? Yeah. Yeah. Okay. Okay. Are you here? Are you in IIT Roorkee here? Okay. Yeah. 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 So it can be a bit challenging to get started, isn't it? So yeah, I mean, just follow the instructions, and the guys are here to help. So yeah, hi. Don't ask me questions; they know better. So how are you doing?
I'm not getting how to proceed.
Hmm?
How to proceed?
How to proceed? Um, how to proceed? I don't know. I don't know what your instructions are. If somebody went a step ahead, what is he doing now?
What problem? So this is the general content base. So we have provided to all the PDF file. Okay. So in any working phase, so we have provided three folders, three cases, and each case will be in the best size. So in each of one component, there are different types of basic folder. Zeros, constant, and system. Now, before we are going to use zero folder, the folder which contain all types of boundary condition, which you have to define boundary condition. But before defining boundary condition, you have to create mesh. So mesh one code has inbuilt. It's a renewable dictionary, which is a block mesh dictionary. This is an the block mesh dictionary. Okay, so this is the general format. So in the very first line, you have we have written the if you write it one, what it means that you are dealing in meters. Okay, since we have given a scale of 0.001, that means we are working in millimeters. Now, what actually happens in block math is how generally create hexagonal scale. For example, you have this small big unit. You have an
Actually, we work on the one page or two page within the calculator.
unit shape of hexagonal shape, not any particular triceps. You cannot have tetrahedron in block notation. For that, if you want to put tetrahedron,
We have already set up
create a
like
geometry to create an STL file, so we put it over here. But that's another case. But since it is a simple case, it's been working in block math dictionary. So, these are the various vertices that will be used for the creation of the geometry. Now, as I told you that we will mention the angle of this. Now we have to, once we created means what this is a network we have created using block static. So we can show the art of step by step. How do we run? Since it is inbuilt stock, so just write block.
this is our you have to confirm we are just the instructions. Yeah,
This is done.
there is no
You
both
want
are
to look how your geometry has this one. You want to write
run the simulation after setting everything.
with a dummy point.
Go on the terminal, then
And
you
the
load the
path
block man, whatever solver you are using. But you have to load the open box, which open box you are working on. Then you load the block man, post process in the solver. Okay. Yeah, there is, we have done everything here for the instructions. But for the simulation, there is only one page simulation. Only water is flowing inside the capillary. Okay. But in that case, we have explained the two page also. Like for tomorrow, we will discuss about the two page and the
Get
capillary,
there.
where you get the contact angle.
Sorry, half an hour, but you have hours.
Only one fluid.
So the
And tomorrow we will work on the two fluids. And obviously, second fluid is air already inside the capillary before
Yeah.
inserting the liquid. But in the tomorrow we will learn we will insert the two liquids at the inlet. Then they will be dispersed inside the capillary. And we will see how they are interacting and what type of the droplet are forming, what type of the slug length, what is the film thickness around the slug. So for right now, we are just working on the one page inside a capillary, that is a 3D capillary, and the fluid is flowing inside that. And when you will flow two fluid inside the capillary, and there will be the interaction at the inlet. And due to this interaction, like when you will change the surface tension or the viscosity or everything, then by changing all these thermophysical property and the variability of the wall, there will be a different interaction between the fluids. Okay. Like one time I'm flowing oil and second time I'm flowing the water. Third time I'm flowing some organic liquid like the oil. So there will be different interaction every time. But today we are flowing only one fluid. On the paraform. You will type the after running the simulation, paraform, paraviewform.com. Yes. Yeah. Mhm. It's on this. So right now we don't have any simulation, so you will see nothing. After the running the simulation, you can see everything on the paraview. To not find the valid open form match. Actually, we don't haven't load the block match. Okay. So now you can visualize. You can change the axis, that is the front, back, everything. You can cut also like. Let's not access. And then you can circulate with the edges, how the matching is going on. So this is the matching. Yeah, matching in the block match. Yeah, I will. Yeah, like this is the front. Like liquid is going from here, and the other part is outlet. This is the inlet.
Create a hold, create an empty hold. How create an empty hold? Before you doing the having the food, you have to the hold it the food contact.
This one. Yeah. Actually, there is form.com, one dummy file. By using this will build only particular simulation. Like we have three files like pipe 0, pipe 1, pipe 2. But when you will create form.com for the pipe 0, and when you will select form.com from the pipe 0 to the paraview, then they will create the simulation of pipe 0 only. So that is a dummy file for that.
Like how to create a, for example, if I have to create a folder, so you determine how to do this.
How to?
So to create a folder, how to create an empty folder by which that what is this method?
Just type that command, touch form.com, then it will create a form.com. We have already created, then it will show. You can delete that form.com, then again create one by one, point by point. First delete form.com and cut this simulation, then load the block map directly by going on the.
Okay.
Yeah. It will.
What
You have already. ये 4 बजे आ जाना। क्या? अच्छा। ठीक ठीक। भैया 4 बजे केमिकल में भेज देना गाड़ी। आओ। हो गया? बोलना है, थोड़ा सा बोलना पड़ेगा। ठीक है, मैं बोल देता हूँ थोड़ा सा, है ना। तो ये ऑन है माइक, इधर कर लेना फोकस। करूँ स्टार्ट? Good afternoon, everyone. So today we are performing the tutorial 4, and in tutorial 4 we will learn about the basics of the open form, and we will perform the simulation by using the two-phase flow in the capillary 3D capillary. So here we have already installed the open form 11 in all your desktops, and we have one PPT. You can see from that, like we have written all the steps you have to follow, and we will do it in 4 steps. First we have to install the software, which we have already did. And in the second step, we will do the pre-processing. In the pre-processing, you have to learn about how to form the geometry and how we can change the matching of the geometry for the different kind of the simulations. In the second step, we will see the processing. In the processing, we will learn about the how we have to give the boundary conditions for the pipe wall, and how we have to find out the interface between the two fluids. And in the last, after performing the simulation, we have to see how we have to visualize the results in the ParaView software. So here we have three directory like zero, constant, and system, and I have written everything about like what we have in the zero. Like in the zero directory, we have to give the boundary conditions, and in the constant directory, we have to give the physical properties of all the fluids we are using. And in the system directory, we have to create the geometry, like we are creating the geometry here in the block mesh, and how we have to discretize that geometry, how to refine the geometry. We have to do this in the block mesh, and it will be did in the system directory. And when you will open the zero folder, then you have to find like we have three different directory. One is phase fraction directory, where we have to give the fractions, like if we are using the two different fluids, or one is air or whatever, we have to give the phase fraction for that. Like in that kind of simulation, we are using one for the water and zero for the air. Actually, right now, today we will perform only simulation by using the one fluid only. So air is already in the walls. Sorry, air is already in the tube. So we are injecting the water from the inlet. So here we have initialized the air by the zero and the water by the one. And in the second directive, we have to give the pressure boundary condition, and in the third one, we have to give the what velocity we are performing the simulations. And in the second, you can see like we have to give the values of the gravity value and the physical property of the liquids and the air. And in the third one, we you can see there's a directive of the turbulence properties. If the simulation is turbulent, then only you have to write the turbulence. Otherwise, like we are using the laminar, then after opening that, you have to write the laminar. So in the system folder, you can see we have block mesh and control dict. In the block mesh, we are generating the geometry and the meshing. And in case of the control dict, we are giving the step size of the saving the simulation results. And we can give the time in the control dict. And one is decompose per dict. If we have different core system, then you can decompose the simulation, then it will be run parallel. Like if you have 100 cores, then you can decompose into 100 core, and the simulation will be run parallel in the 100. And third one, okay, these are okay. So now you can see we have attached one photo of that block mesh. So you can see how we are giving the scaling and the vertices of the geometry, and what is the length, how we are giving the length and everything. So after specifying all these properties, so you have to open the terminal. After opening the terminal, you have to load the mesh by typing the block mesh. After loading the block mesh, you for running the simulation, if the simulation is running in on one core, then you have to tap the interform. But in case if you have decomposed the you have used the decompose per dict, then you have to use MPI run minus MP interform minus parallel. So all the simulation will be run in the parallel. ठीक है भैया, thank you.